Good morning, all of you. Myself, Rina, and I am going to present carbon nanotubes from research to application. First of all, I am going to tell the brief outline of my presentation, starting with the introduction and then discovery of carbon nanotubes, types of carbon nanotubes, how to synthesize carbon nanotubes, applications of carbon nanotubes, advantages and disadvantages of carbon nanotubes, and ends with conclusion. Now, let's get started with brief introduction. At first, we have to know what is carbon nanotubes. A graphene sheet which has been rolled up into a cylindrical shape to form tube-like structure is called carbon nanotubes. Carbon nanotubes have gained return in recent time due to their extraordinary physicochemical properties like strength, flexibility, sensors, conducting, etc. Carbon nanotubes made of carbon and has diameter on the nanometer scale. Secondly, discovery of carbon nanotubes. Carbon nanotubes were discovered in 1991 by the Japanese electron microscopist Sumio Lijimanek accidentally while studying the surface of graphite electrode used in electric arc research. Let's see types of carbon nanotubes. Carbon nanotubes are broadly classified into two types based on the number of layers. First is single wall carbon nanotubes and second one is multi-wall carbon nanotubes. Let's see single wall carbon nanotubes. In a single wall carbon nanotubes, only one graphene sheet is used to form the nanotubes. They have diameter close to 1 nanometer and tube length may vary millions of times longer. Carbon nanotubes having three basic structures. One is armchair, another one is zigzag, and the third one is chiral. Let's see what is armchair, zigzag, and chiral. Firstly, armchair. The armchair structure of carbon nanotubes can be made by rolling that graphene sheet in such way that carbon-carbon bonds should be parallel to the tube axis. Secondly, zigzag. The zigzag structure is made by rolling the graphene sheet such way that the tube axis is perpendicular to the carbon-carbon bonds. And the third one is chiral. In the chiral structure of carbon nanotubes, carbon-carbon bonds are inclined to the direction of tube axis. These three types of single-wall carbon nanotubes are formed by folding of graphene sheet in three different ways. The zigzag and armchair single-wall carbon nanotubes are achiral, while helical single-wall carbon nanotubes is chiral. The armchair single-wall carbon nanotube shows electrical conductivity, but zigzag and helical single-wall carbon nanotubes act as conductor. Let's see multi-wall carbon nanotubes. Multi-wall carbon nanotubes is multiple rolled layers or concentric tubes of graphene. Let's see how to synthesize carbon nanotubes. Carbon nanotubes have different preparation methods like arc research, laser ablation, chemical vapor deposition, as well as some of the more recent methods working with high pressure of the carbon nanotubes, carbon monoxide, or some unique catalytic mixture. So we are going to prepare in two ways. One is arc research method and another one is chemical vapor deposition. Let's see arc research method. Arc में electricity, we will apply electricity at high voltage and we suddenly discharge to the electricity. That is a process involving in preparation of carbon nanotubes. We can see here there is a vacuum. So there is a vacuum created within a cell. So in each cell one glass tube is there. That glass tube anode and cathode is there. So electrode minus cathode minus charge possessing cathode to connected to battery negative. At cathode a graphite rod. A simple graphite rod is connected to cathode. So this chamber is vacuum. And how to pass helium or argon gas at 400 megavolt. Then we need to supply high voltage electricity. When we supply high voltage of electricity, so we were giving electron to the carbon rod. Because of this electrical energy, the carbon-carbon bonds will be vibrated. Then will be activated because of high voltage. And we suddenly discharge the voltage and heat this material at high temperature. When we heat this material at high temperature, already activated carbon-carbon bonds will break and carbon will be evaporated. The evaporated carbon will deposit on this anodic material as a carbon nanotubes. So, what happening here? The solid graphite first activated by using electricity, then the carbon-carbon bonds will be break. And carbon evaporating by using the thermal energy, heat energy. So electrical energy and heat energy combination of these used in the arc discharge method, and finally we get a carbon nanotubes. Generally this method produces 30% yield of the carbon nanotubes, and this method only produces multi-wall carbon nanotubes. Second one is chemical vapor deposition. This is the industrial method most frequently used and best method to prepare the carbon nanotubes. In this method, we need to pass methane gas in presence of hydrogen gas in air into the chamber, which is a 1000 degree Celsius. And also this chamber having a catalyst material. These material are made by cobalt or nickel. So when we passed the gaseous molecule methane, so already it is a gas molecule when we apply 1000 degrees Celsius. So carbon hydrogen bond will break down and its free carbon evaporated. Carbon will be deposited on this catalyst material as the carbon nanotubes. The simple process is called chemical vapor deposition. Let's see applications of carbon nanotubes. Carbon nanotubes are used to destroy the breast cancer tumors. Number 2 is nanotubes are also used in the windmill blades because of their low weight to better wind and produce more electricity at faster rate. Third one is carbon nanotubes can be used to separate particles of size greater than the diameter of carbon nanotubes during filtration through carbon nanotubes. Fourth one is nanotubes are used in the space and aircrafts to reduce the weight and stress of the various components working tighter. Fifth one is carbon nanotubes is used as catalyst in some reactions. Sixth one is carbon nanotube is used in drug delivery system. Seventh one is it has many applications related to conductivity and in electronics. Eighth one is carbon nanotubes can be used to increase the tensile strength of steel. Let's see Advantages of carbon nanotubes. First one is extremely small and lightweight, making excellent replacement for metallic weights. Second one is resources required to produce them are plentiful and many can be made with only a small amount of material. Third one is resistant to temperature changes, meaning function almost just as well as in extremely cold as they do in extreme heat. Fourth one is improved conductive mechanical properties of composites. Let's see disadvantages of carbon nanotubes. Disadvantages of carbon nanotubes: it difficulty in maintaining high quality and minimal properties. Extremely small, so are difficult to work with. Currently, the process relatively expensive to produce the nanotubes. Last one is difficulty in maintaining high quality and minimal impurities. And last one is conclusion. Effect of carbon nanotubes on properties such as compressive strength, tensile strength, modulus of elasticity, flexural strength, porosity, electrical conductivity, and autogenous shrinkage are studied that indicated that the superior mechanical properties of carbon nanotubes were initiated to use this nanomaterial by construction industry. Carbon nanotubes have been extensively studied, making way for basic understanding and potential for various applications. This article has discussed several applications of carbon nanotubes. The remarkable physical properties of carbon nanotubes have created a host of application possibilities based on electronic and mechanical behavior of nanotubes. References, and then thank you.